Mathematical induction, part 1.
Hello everyone. In this session we will discuss new chapter mathematical induction. So in that we have 7 marks question for a intermediate public examination. So this is very easy chapter also. So here first, what is mean by mathematical induction? So simply, which is the checking process or verification method. So which means if any statement is given to check if it is true or false, for that we can use the mathematical induction. So here for example, if the given statement is 1 plus 2 plus 3 plus and so on n, which is equals to n into n plus 1 by 2. So this is any statement to check if it is true or false. For that we can use mathematical induction. If n is equals to 1, so clearly this is LHS and this is RHS. N is equals to 1 means number of terms are 1. So clearly LHS, we can take only one term because of n is 1. Next we can consider RHS. What is RHS? N into n plus 1 by 2. So replace n by 1, that is 1 into 1 plus 1 by 2, which is 1 plus 1 is 2 by 2, clearly 1. So both LHS and RHS is equal. So we can say that the given statement is true for n equals to 1. So next we can take n is equals to 2. So means the number of terms are 2. So we can take first 2 terms. 1 plus 2. So what is LHS? 1 plus 2 is 3. And you can go for RHS again. What is RHS? N into n plus 1 by 2. Here we can replace n by what? 2. So what will you get? 2 into 2 plus 1 by 2. So 2 get cancelled. 2 plus 1, 3. So clearly again LHS, RHS equal. So we can say that the given statement is true for n is equals to 2 also. So next n is equal to 3. So what is LHS? We can consider sum of first 3 terms. That is 1 plus 2 plus 3. Which is what? 1 plus 2, 3. 3 plus 3, 6. Again go for RHS. What is RHS? N into n plus 1 by 2. Replace n by 3. That is 3 into 3 plus 1 by 2. Which is equal to 3 into 3 plus 1. 3 into 4. 12 by 2. Which is equal to 6. Clearly, the given statement is true for n is equal to 3 also. Similarly, n is equal to 4. We can take sum of first 4 terms. That is 1 plus 2 plus 3 plus 4. So what we get? 3 plus 3, 6 plus 4, 10. Similarly for RHS also, n is equal to 4. That is 4 into 4 plus 1 by 2. Which is equals to 2 ones, 2 twos. 2 into 5, 10. So clearly the given statement also true for n is equals to 4. Similarly, it is true for n is equal to 5 also. N is equal to 6 also. Okay. So here the statement is true for n is equals to 1, n is equals to 2, n is equal to 3, n is equals to 4. And so on. Clearly which numbers are what? Natural numbers. So which means here n is belongs to what? Natural numbers. So clearly the given statement is true for natural numbers. You can consider any natural number. For example, let n is equals to k. So already you proved the given statement is true for natural numbers. So let us consider n equal to k. So here k also natural number. So means the statement is true for natural numbers. So the statement is true for n is equal to k also. Next we can take after k number. See here The given statement is true for n is equals to 1. After 1, what will you get? 2 means 1 plus 1. So for n equals to 2 also the statement is true. Next, for n is equal to 3 also the statement is true. So which means the given statement is true for consecutive natural numbers. So clearly from this we can say that for n is equal to k plus 1, the given statement is true. See here, for example, if k is 1, what will you get? Substitute here, n is equals to 1. So already proved n is equals to 1, the statement is true. Next, n is equal to k plus 1, that is what? 1 plus 1, 2. And n is equals to 2 also statement is true. For example, k is equals to 2. Substitute here, n is equals to 2. K plus 1 means 2 plus 1, 3. So from this we can say that the given statement is true for all natural numbers. So this is the concept of mathematical induction. So next, the principle of mathematical induction. See here, the mathematical induction can be done in 4 steps or 4 cases. So first, if any statement is given, let us consider S of n be the given statement. Case 1. In case 1, we have to prove the given statement is true for n equals to 1. So simply you prove for n is equals to 1. That is the first case. In first case, we can consider LHS and RHS separately. Okay. So that is the first case. And go for second case. In the second case, we have to assume the given statement is true for n is equals to k. So simply we can write assume that n is equals to k. So which means we can write directly LHS is equals to RHS. So which means we can replace n by k in the given statement. Okay, that is the second case. Next, case 3. So already proved the mathematical induction is true for consecutive natural numbers. See here, what is the second case? The given statement is true for n is equals to k. After k also statement is true, which means we can prove the given statement is true for n is equals to k plus 1. You prove for n is equals to k plus 1. So clearly from these 3 cases, we can say that the given statement is true for all natural numbers. So that is the case 4. So the next case 4. So this is very important case 4. So because of most of the students miss this step, that is case 4. So this case 4 is we can write by principle of mathematical induction. The given statement, that is what? S of n is true for all natural numbers, that is n belongs to n, or simply positive integers also. So these are the 4 cases in mathematical induction. So these 4 are very important. So based on this, we have 7 marks questions. So total we have 7 marks for these 4 steps. See here, for writing S of n, they will give 1 mark. For proving case 1, again they will give 1 mark. For writing case 2, again they will give 1 mark. Next, case 3. For case 3, we have 3 marks. Next, case 4. For case 4, we have 1 mark. So total 7 marks. Okay. For next session, we will discuss very important problems on the mathematical induction. ఈ వీడియో మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ అండ్ షేర్ చేయండి, సబ్స్క్రైబ్ చేయడం మాత్రం మర్చిపోకండి. థ్యాంక్ యూ.